we let's say this node represents our information or the information of formal logic system, and then we have two nodes A and B which are equipped with this implies relation. So A implies B, let's call it an F. We also have our formal logic system also have another relation, that is proof of A, which basically means that A exists. Let's call it P sub A. Now what we want to prove is that there exists a relation called P sub B which proves the existence of B given this information, right? Let's call it P sub B. How do we prove this in formal logic system? First we're gonna start with the obvious theorem syntax, and let's call this composition by forward proof. In forward proof, basically we type in a complex hypothesis and then solve it bit by bit from left or from right. So forward proof, and then for all A, B, comma, nip semicolon, and the type is prop, and then comma, what's the structure of proof. So let's write A implies B. A implies B. But this isn't really the structure of proof, because A implies, let's call it A goes to B, because there is a relation called A implies B. We also have to include the sub relation. Let's call these arrows goes to, then A goes to A implies B, which goes to B. There isn't any obvious way of representing or differentiating between the objects and the functors. We're going to just use this notation and then write full stop and execute. So now we have a sub goal of proving A goes to A implies B, which goes to B. We're going to write a proof indent and then introduce with intro syntax A, and then intros B, then again intros. Let's run it first. If I look at the right panel, then this for all statement will just reduce to objects. Let's introduce proof of A, because it's already given that A exists, so we also have a proof of A. It's sort of like an identity element. So you can see that we just reduced one element from the proof by introducing proof of A, right? Like you can see here, if we revert back. Now let's go forward. Introducing proof of B can be done by posing the composition of proof of A and A implies B. Proof of B is equal to A implies B and proof of A. It becomes A implies B underscore B and then space proof underscore A. Proof of B is the composition of these relations. If we look at this in our diagram, it sort of looks like the composition of F and B of A equals P sub B. If I execute this statement, then I will have proof of B. Nope, I get an error. It says I forgot to introduce A implies B, which is not defined. I forgot to define it. Let's introduce it. Intros A underscore implies underscore B and run the statement. A implies B is gone from our sub goal, and if we move into the proof statement, then we only have B. But if you look at the right window, we still have something left to prove, and we can prove that by exact tactic, which basically states that we have a proof of B. We'll have a proof of B, no more subgoals. That's it.